Hi everyone. Welcome to the derivative discussion using chain rule part 3. Okay, so let's go ahead and start right away at problem number 34. All right, so given this function x squared over 5 raised to the third power, demonstrate the chain rule. So what we do is multiply 3 and 1, so that's your 3, and then copy that same base x squared over 5, now raised to 3 minus 1, which is 2. Okay, now it's a chain rule because it's a combination of a power rule. So this is actually a power rule with one extra step. Okay, so there's one step that we have to do, one additional step, which is to multiply what we have right now by the derivative of this base, which is 2x over 5. Okay, so that makes it a chain. And the final answer that we have right now is 6. So what I do, I multiply 3 and 2x. That gives me 6x over 5. And I can also, raise this x squared over 5 to the second power, which is x to the fourth over 25. And then finally, I can multiply these two terms, which is now equal to 6x to the fifth over 25 times 5 is 125. Okay, now alternatively, we can also, okay, if you don't want to use the chain rule, we can alternatively use power rule, but you have to rename, okay, like use algebra initially by simplifying that x squared over 5 to the third power, which is also equal to x to the 6 over 5 cubed, okay, which is 125. And then from here, you can go ahead and use the power rule. So that's going to equal to 6x to the fifth over 125, okay? So at this point, you can see that when you rename it, now this is very easy to rename. All right. So when you do realize that it's easier to do the algebra, rename it so that you can use the power rule. Okay. Sometimes that's the easy route. Okay. To find the derivative. Okay. Let's go ahead and look at number 35. All right. So let's say we have 5 over x squared instead. Okay. So I inverted the x squared over 5. Now I have 5 over x squared raised to the third, and go ahead and find the derivative. So it's like prime. Now, hopefully you realize that this is a reciprocal right here. Okay, we have a constant numerator. Our numerator is 5, which is constant, and then we have a variable x raised to some exponent as our denominator. So we have a reciprocal. And we develop a shortcut, to find the derivative of those types. So let's go ahead and find the derivative using the chain rule. So using the chain rule, I'm going to go ahead and multiply 3 times 1, which is 3, and then copy that base, all right, that 5 over x squared, and then raise it to the second power, 3 minus 1, and then multiply this by the derivative of the 5 over x squared. All right, the shortcut that we studied before is to get the derivative of this reciprocal, we multiply 5 and 2, okay, that's 10, over x raised to 2 plus 1. And that's it. So easy, okay? Also, don't forget to switch the sign. Now, all we have to do is just raise this to the second power, which is 25 over x to the fourth, multiplied by negative 10 over x cubed, okay? And again, 25 times 3 is 75 times negative 10 is negative 750 over x to the 7. You added the exponent 4 and 3. Okay? Now, alternatively, we can also use algebra just like in number 34. So if you want to rename that, 5 over x squared raised to the third power, that's 125 over x to the 6. And then you get the derivative of this expression right now. Now, this is a reciprocal. So the shortcut that we develop is what we do multiply 125 times 6. So 125 times 6 is going to be 750 over x raised to 6 plus 1, 7, and then switch the sign of that original expression. Okay, so again, because the algebra involved here is a simple one, you can see that once we rename it, the next step, the actual differentiation is easy, actually easier. Okay, so you can see both ways. 36, the derivative of, okay, find the derivative of negative x cubed, let's say over 2, and then raise it to the second power. Right. So what we have right now, this is not reciprocal because we have a variable x on the numerator. Okay. So using the chain rule, I'm gonna use chain rule and also renaming algebra and then power rule. Okay. So right now, let's demonstrate the chain rule. So multiply 2 and 1, that's 2. Okay, copy the base, that same base, negative x squared over 2, sorry, negative x cubed, okay, over 2. Now raise to 2 minus 1. So it's just going to be 1 right here. And then chain. So this is the chain multiplied by the derivative of the negative x cubed over 2, which is negative 3x squared over 2. Okay, and then simplify. So I can cancel these 2's here. And then the negative times the negative is a positive, okay, 3x. Now, 3 plus 2 exponent, okay, is 5 over 2 over this 2. So that's the chain rule. Now, the alternative method to finding the derivative is what we do, because again, that is very simple to rename, okay? So the negative x cubed over 2 and then raise it to the second power is going to give us x to the 6, okay? So this time you multiply the inside and outside exponent over, now the exponent of 2 is 1, so you can also multiply the 2 to that 1, that makes it 2 squared or 4, okay? So after we rename it, then we can just use the power rule, which is 6x to the 5th, okay, over 4, and then reduce that by 2, okay, which is 3x5 over 2. So you can see that we got the same expression answer. Okay, number 37. How about if we have negative 7 over x cubed squared? So I inverted again the x cubed over 7. Now I have 7 over x cubed, and that makes this a reciprocal. Okay, so if it's a reciprocal, then we have a shortcut for finding the derivative. Now using the chain rule, so what we do is multiply 2 and 1, that's 2, and then copy the base, negative 7 over x cubed, okay, the base of the exponent 2, okay? 2 minus 1 is now 1. And then this is the chain part. Multiply this by the reciprocal of the 7 over 3. All right, this is where the shortcut for the derivative of reciprocal is applied. So you multiply 7 and 3, that's 21, over x to the 3 plus 1, 4. And then from negative, we switch to positive. All right, so we just need to simplify our x cubed times x to the 4th is x to the 7, okay? And the top is 2 times 7, which is 14. Then 14 times 21 is 294 negative. Okay, so this is our derivative. Now, if this is something you can rename, okay, so this is the alternative method, like you rename it if you can. So this negative 7 over x cubed, when raised to the second power, is now positive 49 over x to the 6. Now this, again, is a reciprocal. We have a constant numerator, and then we have this variable x raised to some exponent at the bottom. So the shortcut says we multiply what? 49 times 6. 49 times 6 is going to give us 294 over that same base x raised to 6 plus 1, now 7. And then we switch the sign every time we use this shortcut. Okay? So you can see that they are equivalent. Okay, number 38. How about going back to our square root? All right, so we have a shortcut for the square root on how you get the derivative. And by memorizing it, you say 1 over 2 square root of x. Okay, so that's the shortcut for our differentiation of square root of x. Now, when we have something like a 4 and then square root of something more complicated than x, okay? Let's say we have this 3x squared plus 5x inside the radical sign. How do we get the square root? I mean, the derivative of that square root. So this is a constant. We just bring it down. And then on this part right here, we're going to be using the shortcut, okay? So the structure will be the same. It's going to be 1 over, just like this. It's 1 over 2, the square root of. So 1 over 2, the square root of, but instead of x, we have this 3x squared plus 5x. Now, because this is no longer plain x, we have to make a chain rule out of this, right? Meaning you have to multiply what we have right now by the derivative of that 3x squared plus 5x, which is 6x plus 5. Okay? So now, our derivative is going to be, all right, 2 times that 6x plus 5 over square root of the 3x squared plus 5x. Right? So just don't forget to use chain rule when the expression inside the square root is more complicated than plain x. Now the reason we don't have to use the chain rule here because when you get the derivative of x, it's just gonna be 1 anyway. So even if you multiply it by 1, you're still gonna get that same 1 over 2 square root of x. Okay, so number 39. Let's say you have cube root instead. Cube root of 3x squared plus 5x. So what is the derivative? Okay, so if it's something like cube root or fourth root, then we have to change this to rational exponent, like 3x squared plus 5x, okay? And raised to what? 1 over 3, okay? Then we can use the chain rule. So 1/3 times 5 is 5 over 3 multiplied by that base 3x squared plus 5x raised to 1/3 minus 1 or 1/3 minus 3 over 3. And then multiply it by the derivative of this base here, which is 6x plus 5. And then simplify. Okay, so we got 5 over 3, 3x squared plus 5x raised to negative 2/3 times 6x plus 5. Okay. Now we can move this down. Okay, if you move it down, then we will have a 5 and the 6x plus 5 as our numerator. And then our denominator is going to be 3. Now that 3x squared plus 5x raised to from negative 2/3 now to positive 2/3. Okay, good job. Number 40. Let's talk about natural log. One more time, what is the derivative of natural log of x? So the natural log of u, okay, again, u is a function of x. So this is more general, okay? The natural log of u, what we do is get the derivative of the u prime, divided by that u, okay? So if we have our u here is x, so the function is in terms of x. Let's say it's just plain x. So the u prime means the derivative of that inside the parenthesis is 1 over that same x right there, okay? So the natural log of x, its derivative, okay? So natural log of x prime is 1 over x, okay? Then derivative of natural log of u is u prime over u. So if we have natural log of 5x, the derivative is going to be what? First, you get the derivative of 5x, which is 5, over that same 5x, okay? And then reduce into 1 over x. Okay, so let's say 41, say 41, okay? Natural log of, how about if it's 5x plus 4 squared? Now you can do it this way, see? If you want to do like raise this to the second power, which is 25x squared plus, 20x plus 40x plus 16, and then you get the derivative. Okay, so this is like, okay, what is this prime, meaning what is the derivative? So what we did is just rename it initially, and now we can get the derivative by using the u prime over u, or get the derivative of this first, which is 50x plus 40 over that same 25x squared plus 40x plus 16. Okay. Now, alternatively, if you remember the property of logarithm, there are like three of them. One of the properties of log has something to do with the exponent. Like if you have the logarithm, say the natural log of x to the n, okay, so that's equivalent to n, okay? So you can move this n right out front, which is n natural log of x. So you can multiply the natural log of x by n, okay? We can apply it here. So if you want to do the algebra first, so we can move the 2 as the multiplier of your natural log of 5x plus 4. And then you go ahead, this is constant anyway. So the derivative of 5x plus 4 is going to be 5 over that 5x plus 4. Now it's equal to what? 10 over 5x plus 4. Say, how come this is not the same as that one? Okay, let's see if we can still simplify this. 50 and 40, they are divisible by 10, right? So if I factor out the 10, then we get 5x plus 4, okay? And downstairs, we can factor that into what? 5x plus 4, 5x plus 4. And this you can cancel, and what's left? 10 over 5x plus 4. So as you can see, again, this property of logarithm makes the differentiation process easier, okay? So it's a good strategy to apply the property of log before you get the differentiation or the derivative, right? So there you go. 2 times and then you get this is the renaming part right here, okay? And then the derivative process begins right here. Okay, so let's look at number 42. How about if we have to get the natural log of square root of 3x plus 5? Okay, so let's use again that property of logarithm. If we have the natural log of x raised to, say, n, that's equivalent to n times the natural log of x. In other words, if we have the natural log of x squared, this is the same as 2 times the natural log of x. So let's say this is the y, so we can rename this as natural log of 3x plus 5 raised to what? 1 half. And then continue renaming. This is also equivalent to 1 half natural log of 3x plus 5, okay? Using the property of log. Now, this is where the derivative going to start. 1 half is a constant, bring it down, and then the derivative of natural log of 3x plus 5 is 3 over 3x plus 5. All right, thus we have 3 over 2, quantity 3x plus 5 as our final answer. Okay, how about this one? Let's talk about exponential functions. Let's say y equals e to the x. What is the derivative again? It's itself, right? The derivative of e to the x is e to the x. So whenever we have something like e to the 2x, now this is going to look more like a chain rule because when you get the derivative of e to the 2x, so what we do is, right? So we copy that e to the 2x just like this. We copy the e to the x, but to use the chain, you have to multiply this by the derivative of 2x, which is what? 2. The reason we didn't emphasize it here because the derivative of x is 1 anyway. So it's just going to give us the same e to the x. So e to the x, its derivative is 2 e to the 2x. Let's say 45. What about y equals negative 4 e to the 3x plus 2? So its derivative is negative 4 e to the 3x plus 2. Okay, cover everything down, multiplied by the derivative of the exponent of e, which is what? 3. Okay, so our final derivative is negative 12 from negative 4 times 3 e to the 3x plus 2. Okay, 46. Let's say we have e to the sine x. All right, so the derivative is going to be e to the sine x times what? The derivative of sine x, which is cosine x. So the derivative is cosine of x e to the sine x. Okay, number 47. Okay, let's say 47. Y e to the x to the fifth plus e to the x raised to 99. So here, let's use the chain rule. Okay, so what we have is 99 times 1 is 99. Then x to the fifth plus e to the x. All right, 99 minus 1 is now 98. Now, what is the derivative of this x to the fifth plus e to the x? We got 5x to the fourth plus e to the x. Okay, so that's it. We have 99 you want to rearrange it, times 5x to the fourth plus e to the x times x to the fifth plus e to the x raised to 98. Okay, let's look at number 48. Let's say we have again this trig function cosine to the fifth of 3x plus 2. Okay, in the second part of this derivative chain rule series, I showed you something like cosine to the fifth of x. Okay, so this is like plain x right here. And the way you start doing the differentiation is I recommended to rewrite this as cosine of x and then everything raised to the fifth. Okay, so that you can see very well what the base is. Then the chain rule begins right here. Say 5 times 1 is 5. Copy the base cosine x and then raise to the fourth and then make it a chain by multiplying everything by the derivative of that cosine x, which is negative sine x. All right, so that's it. You got negative 5 sine x, and then cosine of x to the fourth is the same as cosine to the fourth of x. All right, so this is how you do it. When this is plane x, if it's no longer plane x, say 3x plus 2, how do we do that? So y equals cosine of 3x plus 2. So we're going to be following that same step. We're going to rewrite this in a way where the exponent is outside the quantity. So you can see again very well what the base is. Now use the chain rule. So it's 5 times what? Cosine of that base, cosine 3x plus 2, and then raise to the fourth, and then multiply everything by the derivative of this base. Okay? So this is the derivative, this is the base, and go ahead and find the derivative of that. So if I'm going to say, all right, let g of x be that cosine 3x plus 2, right? So I assign this to function g. What is its derivative? So we have to use the chain rule, right? So it's a chain rule within a chain rule. The derivative of cosine is negative sine 3x plus 2, but this is not plain x, so we have to multiply this by the derivative of 3x plus 2, which is 3. All right, so g prime of x is negative 3 sine of 3x plus 2. Okay, so the 3x plus 2 is going to stay. Okay, just get the derivative of the cosine, which is negative sine, copy this same quantity here, and then multiply by the derivative of that quantity. Okay, so this g prime of x, all right, is this part over here, negative 3 sine of 3x plus 2. Okay, so just clean this up. It's going to be negative 3 times 5, which is negative 15 sine of 3x plus 2 times cosine of 3x plus 2 to the fourth, or you can say cosine to the fourth of 3x plus 2. All right, let's look at number 49. How about if it's secant cube of cosine x? All right, so let's go ahead and rewrite this as secant of cosine x, everything raised to the third. Okay, so they mean the same. So the chain rule says multiply 3 times 1. Okay, copy that same base, secant cosine of x, now raise to the second power, and multiply everything, okay, by the derivative of that secant cosine x. So again, I'm going to assign that to a function g, cosine x. What is its derivative? Okay, Right, so we need to get the derivative of secant cosine x. Okay, so the derivative of secant is secant tangent, okay? So what's going to happen is it's going to be like secant cosine x times tangent cosine x, and then multiply, this is the chain part, multiply it by the derivative of the cosine, see? And the derivative of the cosine is what? Negative sine x. Okay, so this is going to go inside this box. So multiplied by negative what? Sine x secant cosine x, and then tangent cosine x. All right, so just clean this up. It's negative 3 because you have a negative here. So negative 3. Okay, I'm just gonna write down all of this. Sine x secant cosine x tangent cosine x. Okay, and this one, which is times secant squared of cosine x. Okay, last number. Let's say, what happens if it's a cotangent squared of cosine 3x? Right, so let's rewrite this again as cotangent of cosine 3x. Okay, everything raised to what? 2. So the y prime is going to be 2 times 1, which is 2. Cotangent of cosine 3x to the 1. Okay, 2 times 1 is 2. Cotangent of cosine 3x raised to the first and multiply by the derivative of this. Okay, so we have to get the derivative of that cotangent of cosine 3x. Okay, so what is the derivative of cotangent cosine 3x? Let's say g of x equals cotangent cosine 3x. The derivative g prime of x is what? The derivative of cotangent is negative cosecant squared of cosine 3x. All right, and then multiply by the derivative of cosine 3x, which is what? So what is the derivative of cosine 3x? So the derivative of cosine 3x, that's another function. Let's say h of x is cosine 3x. The derivative is what? It's negative sine 3x times 3. Okay? Times 3. So this is going to be negative 3 sine 3x. So all of this will go inside this box. So we're gonna start with negative. Okay, negative times negative. I see two negatives here. So now it's a positive. Okay, positive 3 sine 3x. And then cosecant squared of cosine 3x. Alright, so this is everything. Okay, so 2 times 3 is 6. I see 2 here and also 3 here. So that's 2 times 3 is 6. I'm just going to organize it. Okay, I'm going to start with this one. Sine 3x. And then cosecant squared of cosine 3x. And then cotangent of cosine 3x. Right, so this is our final answer. Okay, so hopefully that helped, and I appreciate you for watching, and see you again next time.